Hey, good morning. Today we are going to take a look at May 11th lesson for geometry. Glad you're all here. We are continuing on with more volume. This week we're looking at oblique prisms and pyramids. And again, here's our standards that we're building on, just so you guys know again that we are working off of guiding principles here. So our goal is to find the volume of oblique prisms and cylinders and oblique pyramids and cones. We will have an extension, a surface of area of oblique prisms, and please remember to add your name to the attendance forms. Now these are two stacks of quarters. They contain the same number of coins. And our question to you today is, how are these two prisms alike and how are they different? Giving you a couple seconds to think through this, and you might notice, well, hey, they're all made out of quarters, same number of quarters. One of them has the quarters all stacked nice and neat on top of each other, and the other one's kind of going off at an angle. And you would be correct on all those accounts. This is a stack, it looks kind of like a cylinder, and this one looks like a cylinder that's kind of slanted, and we call that concept oblique. Oblique. That's what it means to be oblique. And you might be wondering, what the heck is this oblique stuff? So, in summary, here we have what would be called a right prism. This would be an oblique prism. So the right prism is similar to the oblique prism. They're very similar to each other. One is just slanted. So our big question is, what about the volume? What do you think is going to happen when we look at volume of these? And just think about, would the volume be the same? Would it be different? How would we know? Well, as some of you may have guessed, the volume of the two figures is exactly the same. The only difference is that we've kind of slanted one. If we were to make it perpendicular again, instead of at that slanted angle, so to speak, they would have the exact same volume. So what we do to find the volume, and we're going to look at an oblique cylinder, but it's the same for a prism. Basically, to find the volume of any figure, we know that we find the area of the base, and then we take it times the height. In this case, our height, though, is perpendicular, as always. It's not going to be found by connecting the two centers of these circles, because if we were to connect the two centers of these circles, the one at the bottom and the one at the top, we would find that line would not be perpendicular to the base. So we would need to find the line that is perpendicular. We call that our height. So to find the volume of an oblique cylinder, you may have already guessed it. I'm going to scroll this down for you. We find the area of the base, and then we multiply it by the height. So that was our big B that we've used before, the area of the base. So this base is a circle. So to find the area of the base, that's going to be pi r squared. Our radius is the r. Radius is 5. So 5 squared is 25. So it's going to be 25 pi square centimeters. And then we take that times 15. So the height is 15. And to find the volume, then we would take that 25 pi times 15 and see that that's 375 pi cubic centimeters, again, because volume is three-dimensional. So we're going, the base times the height gives us a third dimension. Okay? So what happens if we don't have the height? So if we have this kind of situation where they're telling us, okay, we have this slant height. Our slant height is 15 meters, but what do we do with that? We have our radius at the top is 4 meters. It's going to be the same at the bottom because these are the two circles are exactly the same area. So what we have to do in this case, and hopefully you guys are figuring it out, Leipold, you've got a triangle there. Yep, I do, and it's a right triangle. So we're going to be doing our Pythagorean theorem. Use Pythagoras, he's coming back at us again. So to find the area of the base, we have to find the volume, we find the area of the base and then multiply it by the height. But in this case, we first need to find the height. Once we found the area of the base, that's easy. It's 16 pi square centimeters. And then we have to use the Pythagorean theorem to find the height. And we do that by realizing that 9 squared plus h squared is going to be 15 squared. 9 squared is 81 plus our h squared is going to equal 15 squared. That's 225. And then h squared, we get the 144 by subtracting 81 from the 225. And so since h squared is 144, that means that h is going to be 12. That's the height is going to be 12. So then we just take 16 pi times 12, and that gives us 192 pi cubic meters. So sometimes, I guess the thing that we're picking up here is that sometimes we may have to use the Pythagorean theorem to determine the height. And this works again for all figures, whether it's a cylinder, a cone, a pyramid, they all work exactly the same. Okay, we're going to go to a square oblique next. So this is a square oblique prism. And so our base is a square. It doesn't look really square, but it is. And so in this case, you can see we have this length here of our right triangle. We have the slant height, which is 14 centimeters, but what we don't have is the height of that prism. So we are going to have to find that value. So let's take a look. So here it is with everything marked in color for us. To find this, again, the volume is the area of the base times the height for every figure that we're looking at. Area of the base times the height. When it comes to cylinders and pyramids, that would be base times height, and then we divide that by 3, remember. So we again have to use the Pythagorean theorem to find the height. So we have 5 squared plus h squared is 14 squared. So that's 25 squared plus h squared is 196. H squared then is 171, or we can round that to, you find the square root of 171, and that's going to be about 13.1. So then we use that for the height in the formula as before. We take that area of the base. It's a square with the side lengths of 6. So we're going to take 6 times 6, which is 36. Multiply that times 13.1, and we get 471.6. Should be cubic centimeters. Whoops, I've got a typo again, you guys. That should be cubic centimeters. Okay, because we're doing volume. All right. So make sure you fix that in your notes. So here is kind of an extension. How would we find the surface area of this square oblique prism? What would we need to do with that? And you may say, well, all we do is find the area of each surface, and you're absolutely correct. It's just that some of these surfaces are parallelograms, so we have to think through how that would work in this particular instance. So we find the area of all the sides, as you suspected. We know that the top and the bottom, the base and the top, are both squares 6 by 6, so that's going to be 36, right? And then we know that the front and back are 6 times 13.1. Now, we got that 13.1 by using the Pythagorean theorem on the last slide. So that's our 13.1. So it's going to be 6 times 13.1, or 78.6, and each of those are the same. And then the left and right are going to be 6 times 14. 6 times 14 are 84. Alrighty, because those are rectangles again. And then what we do here is we add all those up, and we get 36 plus 36, 78.6 plus 78.6, 84 plus 84, and that's going to give us a grand total of 397.2 square centimeters. Now this one is actually square. That is not a typo on this one because we're talking about surface area, and surface area means if we were going to cover this with paint, or we were going to cover it with paper, you know, that's going to be a square. That's going to be square units. So it's going to be our centimeters are going to be centimeters squared. Okay, so at this time, I just want to thank you for being here, for looking this over. Make sure you check out the online exit tickets, And if you have any questions, as usual, please give me an email, drop me a line, or stop by during our office hours, and would love to see you. Take care.